All right, we've got 7.3, multiplication properties of exponents here. So let's have a little look. First of all, we remember from last time that we have our coefficient. We've got our base here, that's the variable, and we've got our exponent here. So when you're multiplying powers with the same base, in this case, the base is x. So it looks exactly like the other one. X is the same as x. So x to the fifth, this guy, is really x times x times x times x times x. 1, 2, 3, 4, 5. Yep. Times x squared. So times x squared, which is x times x. So instead of going through all this trouble of multiplying all these different x's, right, we've got 1, 2, 3, 4, 5, 6, 7 of them. So that's really x to the 7th. Okay? But instead of multiplying all these guys together, we should notice what's happening here. We've got 5 of them here, 2 of them here. So for a total of 7. So we just learned that if you have the same base, in this case, it's x, then you can just keep that same base, x, and then just add the exponents. Okay? So in the second case, we've got x to the 412th, x to the 5th, and x. Once again, we've got the same base, x. So we're going to keep the same base, add the exponents. 412 plus 5, that's 417, plus the implied 1 right here. So that's really 418. So on the last example, we have the same base, 3. So the rule is keep the same base, add the exponents. 2 plus 21 plus 4 would give us 27. So 3 to the 27th. So keep the same base, add the exponents. So this is the general rule. A to the m times a to the n. Keep the same base, just add the exponents. Okay. So let's say I've got 3x squared times the quantity of negative 4x to the 5th times the quantity 2x. So the order that you're going to multiply, you're going to multiply your coefficients, so your numbers, then we'll do our bases. So let's look at our coefficients. We've got 3, we've got negative 4, and we've got 2. So if we multiply those, we'll get negative 24. Our bases, well, we have the same base in every case, x. So we've got x squared times x to the 5th times x. So it'll give us x to the 2 plus 5 plus 1, x to the 8th. So our final answer here would be 24x to the 8th. Negative 24x to the 8th. Sorry about that. Negative 24. Good call. All right. So let's see what we get here. Go ahead and do this one. See if you get the same thing I get. So we have negative 15 times 3 times 2. So that would be negative 90. So I'm done with my numbers. So now let's do our bases in alphabetical order. So we have x. So here's 2 plus 1, that's 3. 3 plus negative 2 would be 1. So 90x. We don't write the 1. It's implied. We all know it's there. Then I've got y times y to the 5th times y cubed. Keep the same base. Add the exponents. 1 plus 5, that's 6, plus 3, 9. So negative 90x y to the 9th. The 9 only applies to the y. All right. So let's find the area of this rectangle. Well, we know that area equals length times width. So our length, 24x minus 3y squared times our width, 2x squared y. So what's going to happen here? We're going to distribute. So if I distribute I'm going to take the 2x squared y and multiply times both of the guys in parentheses, a little distribution. So first, 2x squared y times 24x. I do my numbers, then my variables alphabetically. So 2 times 24, 48. X times x squared. That'd be x cubed. Then we just have the y. So now let's multiply times the second guy. So negative 3 times 2, negative 6. Then we have x squared. Then we have y squared times y cubed. So 48x cubed y minus 6x squared y cubed. Okay, let's find the area of this triangle. We know that area equals base times height divided by 2, or 1/2 base times height. Same thing. So we've got 2x squared y times 24x minus 3y squared. Okay. It's the same numbers we had last time. It's just now, instead of having the full rectangle, we only have half of it. So it should be the same as our answer on the previous problem, but half of that. So we've got 48 x cubed y minus 6 x squared y cubed divided by 2. So what do we do here? We've got two different expressions in the numerator over the same denominator. So we can break it into two separate fractions, or we can just reduce both of our coefficients, cut them both in half. So that's 24 x cubed y minus 3 x squared y cubed. Okay. Let's find the area of this figure. Well, we could probably break this up into two separate zones and find the area of each. That's one method. Okay. Or we could act like this is an entire rectangle, and then we could subtract this part. I like that way better. So I'm going to find the entire area and then subtract off this part. So total area, if it were an entire rectangle, it'd be 4x length times width. Our width is 5x plus 2x, so 7x would be all the way. So that would be 28, and then x times x, x squared. So now let's find the part right here that we want to subtract off. So the small area would be 2x times x. So that would be 2x squared. So let's subtract that from our entire area. So 28x squared minus 2x squared would leave us with 26x squared. All right. Let's find the surface area of this rectangular prism. So we know the top is the same as the bottom. We know left is the same as the right. And we know the front is the same as the back. So let's find either the top or the bottom, either way, and then we'll double it so that we get both. So I'm looking at the bottom. I see 9b by 4b. 9b times 4b would give us 36b squared. But the top is the same as the bottom, so let's double it so we'll have the top and bottom. So times 2, 72b b squared. So that's top and bottom. So now let's do left and right. I see the right side, 4b by b. So 4b by b, 4b squared. But we know that the left side is the same as the right. So let's double it so we can have both. 8b squared. Front, back. Well, I see the front. We've got 9b by b. So 9b times b, 9b squared. But we need to double it so that we can have the back also. So times 2 gives us 18b squared. So we found all the faces. Let's add them all up. 72 plus 8 would be 80, plus 18 would be 98. B squared. Okay. So, when you're multiplying in scientific notation, you can group the numbers however you'd like. Okay? So first, let's look at 3m squared times 8m to the 6th. So, first we'll do our numbers. We got 3 times 8, 24. We've got m squared times m to the 6th. That's m to the 8th. Remember, multiplying with like bases. Add the exponents. Okay, so that would be, our final answer right there. So this is also known as 3 times m squared times 8 times m to the 6th. Okay, so remember, you could group them however you'd like. The way we did it was our numbers and then our variables. But remember, you really just have 4 chunks multiplied. Order is up to you. So let's look at the next one. We've got 3 times 10 squared times 8 times 10 to the 6th. Really just 4 chunks multiplied. So let's group them. We'll do 3 times 8, 24. Then we have 10 squared times 10 to the 6th. So we're multiplying with like bases. In this case, it's 10. So 24, one of the few times where we're going to use an x for multiply, right, instead of a dot. 24 times 10 to the 2 plus 6, 8. So 24 times 10 to the 8th. However, that is not scientific notation. So if the direction said scientific, I better go ahead and make this number between 1 and 10. 2.4. So I just divided it by 10 to get it to 2.4. So since I divided it by 10, I need to multiply the other guy by 10. Remember, compensate. So multiply by another 10 here, 10 to the 9th. So instead of 24 times 10 to the 8th, we've got 2.4 times 10 to the 9th. Same value, but now it's in the right form. All right. Hope you enjoyed that one.